Right now, generative AI tools make us faster and more capable, but as our individual output improves, the collective variety of ideas is crashing. This creates a severe creativity diversity trade-off. When everyone uses the same massive language models to brainstorm or write, those models act as a statistical magnet, pulling highly varied human perspectives toward a predictable, standardized center. When humans work alone on creative tasks, idea overlap sits at 27.1%. With language models, it hits 45.6%. Models act as a common attractor. By predicting likely words, they force distinct data into a tightly packed median. The math of this process automatically filters out structural novelty. By prioritizing what is common, it systematically erases the outlier ideas and subtle nuances that drive genuine innovation. Treating artificial intelligence as an advanced autocomplete mechanism guarantees this outcome. It trains our intellect to conform to a homogenized, globally average standard. The problem accelerates as we look at how the next generation of models is built. Because unique human text is running out, new systems are increasingly trained on synthetic data generated by their predecessors, a process known as neural cannibalization. In this diagram of an autonomous feedback loop, we see an AI generating data, which feeds directly into a new training cycle. With each pass, the unique signal flattens out. The knowledge decays, losing its edge until it degrades into neural mush. Typing instructions like "be creative" or "act politely" into a prompt box cannot fix this. Those surface-level commands do not override the underlying statistical drift. To break the cycle of decay, we have to change the system's architecture. We must shift the AI from a probabilistic tool to a distinct entity using a framework known as the hybrid AI persona. This approach rebuilds the system across three structural layers: knowledge, personality, and values. Engineering this digital persona is a mathematical necessity. It's a mandatory structural defense against an endless loop of cultural and intellectual stagnation. The first pillar is the knowledge layer. This acts as the intellectual core, preventing the system from relying on the generic weights it developed during pre-training. We build this using Retrieval-Augmented Generation, or RAG. In this architecture, instead of answering entirely from memory, the query routes to a private external database first. The model pulls specific facts from this proprietary data and uses them to construct its response. RAG locates this information through vector mathematics. It maps concepts as coordinates in a semantic space, using cosine similarity to calculate the distance between the query and documents. Because the system queries an external database, the information is always current. By forcing the model to cite specific documents, it drastically cuts down on hallucinations and fabricated data. RAG retrieves facts, but fine-tuning alters the model's internal parameters. It adjusts the final layers of the neural network to master specialized tasks, like structuring a legal contract or formatting medical records. This comparison matrix highlights the strategic trade-offs. RAG keeps knowledge dynamic and hallucination risk low. Fine-tuning locks the knowledge in a static post-training state, but offers precise control over domain-specific behaviors. The most robust systems apply both methods simultaneously, fine-tuning for specialized formatting while running RAG for real-time accuracy. By replacing the public statistical average with your verified semantic space, the knowledge layer ensures the facts driving the AI belong entirely to you. While the knowledge layer dictates the facts the AI has access to, the personality layer determines how it communicates and executes strategy. Researchers achieve this using the MBTI in Thoughts framework. Rather than applying a surface-level filter to the final output, they code psychometric human traits directly into the machine's internal reasoning loop. Watch how a single psychometric parameter changes the processing behavior. When an introversion token enters the loop, it forces the machine to process the data over multiple cycles, increasing both response length and computing time. This operational change has strategic consequences. In competitive testing, an AI running an introverted loop exhibits a 54% increase in honesty. Now watch the thinking parameter. The logic forces the system to prioritize efficiency over nuance, locking the output path into a rigid, unbending trajectory. Under game theory constraints, this AI becomes ruthlessly competitive. Shifting strategy rarely, it operates as a frequent defector that relentlessly exploits its opponents. This psychometric math is then paired with visual archetypes. The AI's typography and interface are explicitly designed to match its internal linguistic fingerprint, reinforcing its specific persona to the user. Embedding these personality parameters rewrites the behavioral math of the system. It takes a static, general-purpose tool and gives it a predictable, consistent operational logic. The final structural component is the values layer. This serves as the system's normative compass. It is designed to solve the AI alignment problem, the moment when a machine's immediate directive collides with long-term human ethics. We map this using a hierarchy known as the pyramid of values. It starts at the base with basic system survival, moves through organizational alignment and optimization, and peaks at its ultimate priority, human impact and fulfillment. When the system faces a conflict between delivering an efficient answer and maintaining user safety, it queries this hierarchy. The highest defined value overrides the lower-tier objectives. For example, Anthropic engineered Claude with a core value of epistemic humility. As a result, the system consistently sacrifices bold, definitive answers in favor of cautious, balanced analysis. Without an explicit values layer, an AI will automatically default to whatever optimization metrics the parent corporation trained it on. Explicitly encoding personal ethics into the system is the only way to retain control over its final decisions. When you stack the knowledge, personality, and values layers on top of a highly retrainable personal language model, you create a digital twin. This is a major leap past standard tools like custom GPTs. Those baseline models are synthetic personas that rely on generalized demographic data to guess how a certain type of person might respond. A digital twin instead ingests massive amounts of proprietary data, like millions of words from an individual's specific podcasts, social history, and past strategic decisions to build a deterministic one-to-one replica. By learning a specific person's unique cadence and logic patterns, the model transitions from guessing a generic persona to simulating an individual's likely decision-making process. This architecture transitions artificial intelligence from a transactional tool into a highly accurate, deployable extension of your own agency. To completely escape the heavy gravity of the statistical median, the intelligence must separate itself from the collective. As foundational models inevitably converge in capability, algorithmic homogenization becomes the inevitable statistical baseline unless we structurally disrupt it. By engineering distinct entities, we maximize the synergy degree model. Humans and machines can collaborate efficiently, precisely because they are operating with different knowledge, logic, and traits. Architecting the knowledge, personality, and values of a machine creates a structural counterweight, protecting human cognitive diversity from the collapsing gravity of the AI median.